Assalamualaikum and greetings. Today we will start our group project presentation for BITS 2413 Network Security Infrastructure and Design. So this is our contents of presentation. We will start with introducing our team members. Firstly, we have me, Alia Batrisha. Next we have Fatin Amira Liana, Doa Muhammad, Yusrina Nur Afika, Nur Fahana Fatiha, and Anastasia Mara. This is the objective of our project. Based on the data collected from Data Science Company, we will analyze the company current setup, user distribution, and service usage to identify security weaknesses and areas for improvement. We specifically focus on strengthening security by integrating our four main tools: VLAN segmentation with SELs, VPN tunneling, AA protocol using Radius, and CM for centralized monitoring. Our aim was not only to improve security but also to ensure that design supports operational efficiency and scalability. We also justified every tool based on the company's new structure, services, and the risk we discovered. So this is the brief recap for the network security design from the assignment 1, and this is how we implement it in Packet Tracer. Now for the IP address scheme, we calculate it using the LSM. So we use the 192.168.10/24 range and divide it into multiple subnets according to department needs. For example, VLAN 10 for human resources uses 192.168.176/29 and so on. We also created /20 subnets for router-to-router links such as R1 to R2 using 100.0.10/30 and R2 to R3 using 100.0.20/30. The loopback addresses were assigned from 209.165 to 00224/37 for external reachability. That's all for me. I will pass to the next presenter for the demonstration.
So for the VLAN segmentation, we configure VLAN for switch 2, 3, and 4. And for this project, there are 8 VLANs in total, which is VLAN 10 until 80. At the switch 2, there are 2 VLAN, which is VLAN 10 and 20. And the name assigned for both VLAN is Human Resources Department for VLAN 10, Finance and Admin Department for VLAN 20. And for the VLAN 30 until 50, the name assigned for them are PMCOE for VLAN 30, Software Services Department for VLAN 40, Smart Department for VLAN 50. We move on to the next switch, which is switch 4. The VLAN assigned to this switch are VLAN 60 until 80. For VLAN 60, the name assigned for this VLAN is Engineering Department. For VLAN 70, Kerisi Saga Department. VLAN 80, Toy Pay Department. And we move on to the next steps, which is enable trunking parts on all switch 2, 3, and 4. Trunks are connections between the switches that allow the switches to exchange information for all VLANs. As you can see here, the assigned port for switch 2 is Gigabyte Ethernet 0/1. VLANs allowed on trunk are VLAN 10 and 20. For switch 3, the assigned port for it is Gigabyte Ethernet 0/1. And the VLANs allowed on the trunk are 30, 40, and 50. For the switch 4, the port assigned to it is Gigabyte Ethernet 0/1, and the VLANs allowed on trunk are 60, 70, and 80. Then we continue to configure trunking interface on router 1, router 2, and router 3. So for the router 1, as you can see here, the interface assigned to it is 0.10, and the IP address assigned is 192.168.1.177. For the Gigabyte Ethernet 0/0.20, the IP address assigned to it is 192.168.1.145. For the router 2, the interface are Gigabyte Ethernet 0/0.30.40 and .50. The IP address assigned to it is 192.168.1.169 for 0.30, 192.168.1.1 for 0.40. And the last one, 192.168.1.161 is for the 0.50. And the last one is for router 3. As you can see here, interface in the router 3 are Gigabyte Ethernet 0/0.60, .70, and .80. IP address assigned to them is 192.168.1.129 for 0.60, 192.168.1.97 for 0.70, 192.168.1.65 for 0.80. Next, we configure a default route on R1, R2, and R3. As you can see here, for the router 1, IP route is 0.0.0.0, 0.0.0.0, and then 100.0.1.2. This is the IP route that we assign to the router 1. And then for the router 2, we assign the default route. As you can see here, the last one is 100.0.1.1, and then 100.0.2.1 is as you can see here. And then for the router 3, as you can see here, the IP route and with 100.0.2.2. Then we configure a standard ACL on R3. We configure standard ACL that permit all the network on R1, but we deny the network on R2. As you can see here, we start with IP access list standard allow router 1. This is for the VLAN 10 and 20, and then we deny this 3, which is VLAN 30, 40, and 50 for the router 2. And then we permit any. And then the interface serial 0/0/1 access group allow router 1 in. I will show you how it can ping. Let's say at the router 3, I'm choosing this PC. Ping 192.168.1.163. As you can see here, what I'm trying to do is I'm trying to ping PC 15 at the VLAN 50 on the R2, which is deny all the network on the R2. So as you can see here, I'm trying to ping and cannot access to the network on the R3. And then we try to ping 192.168.1.149. Here, as you can see here, ping 192.168.1.149 is for the PC5 at the VLAN 20 on the router 1, which is permit. Network on the R1 can access to the network on R3. At the router 2, configure the extended ACL. As you can see here, IP access list extended allow internet. What we're trying to do is, on the internal network can access to the web server, can ping and browser, but the external network, it cannot ping to the web server, but it can browse it. And then the interface is serial 0/0/0 IP access group allow internal out. As you can see here, we have the external network. I'm trying to ping 192.168.1.180. So I'm trying. It destination host unreachable, so it cannot ping at all. But it can browse it to the web server. Also, for example, I'm trying to 192.168.1.180. As you can see here, it can to the web browser. So, for example, I'm trying to do the internet network. As you can see here, it can ping to the web server. And then you can also browse the web.
Next, I will demonstrate GR implement. First, we verify current connectivity. On router 1, we verify the connectivity to R2. It shows successful connectivity to router 2. On router 3, we also verify the connectivity to router 2. It shows successful connectivity. We also verify end-to-end connectivity. On router 3, we ping to router 1. It shows successful connectivity. On router 1, we ping to router 3. It shows successful connectivity. Next step, we configure the GRE tunnel between R1 and R3. On R1, the tunnel will create tunnel interface. Next, we enter tunnel source. And we enter tunnel destination. If done, on router 3, we also create tunnel interface. Next, we configure routing over the tunnel. On R1, we add a route to R3 VLAN network. So on R3, we also add a route to R1 VLAN network. And next, we test end-to-end connectivity. From R1, we ping R2 VLAN interface. We try to ping on VLAN 60, it shows success, right? Next, we try on VLAN 70, it also success. Next, we try on VLAN 80, it also shows successful. From router 3, we also ping VLAN R1 VLAN interface. We try on VLAN 10, next on VLAN 20, also shows success. That's all from GRE panel.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farhana and I'm going to demonstrate the last tools in our project, which is SOC tools. We choose to use UCF as our SOC tools in this project. So I'm going to use a virtual machine environment. So I will use Kali and Splunk in this demonstration. So in this demonstration, I will explain two things, which is when there is a multiple failure login and when there is a new user that add into the system. So first, I will open my virtual machine. So I just need to enter the password of mine. So like this, I already set up it from the first. So I will enter my username and password that I already set up, which is SQL and the password. Okay. So we will use Splunk as an alert for if there are any multiple login failure or any new user that has been added to the system. So we will create an alert first. We will go to search report and alerts. And we need to just create a new alert. For like this, I already create 3 alerts, which is multiple login failure. The second is new user created, and the lastly is suspicious sudo usage. But for this demonstration, I will show you just 2 of this demonstration, which is the multiple login failure and new user created. So we'll go back to the terminal. So in these things, I will use terminals to create a multiple failure login and add user. So first, we will add new user to the system. Sudo add user, which will name this as attacker. And then I need to authorize that it is me that do this thing. And then I need to create a password for the attacker. And now I'm done create a new user. So we will check at the Splunk. Is it detected that there's a new user? So we will go to Splunk here. We are at the alert page. So we will go back to here, search and reporting. We can search it here, but because we already create an alert, we can search it right there if there is any update of any new user in our system. Check the new user created. So we will open in search here, and it will direct us to where the lists are. So here. So this one already lists that there's a new user that is set into the system like this. Time 12:54 AM at 22 June 2025. Type at user. So it search using a keyword user at. So this is our username that we have and created for the system. So next, we will do a multiple failure login. So we go back to the terminal. We go back here and we choose to login as attacker 1. So we will use that sudo attacker _1. So it asks a password. So I will insert the incorrect password because we want to see the list of what happened here. So I will enter the wrong password. And you'll say authentication failure. So I will repeat it again 3 times and we'll see what happened. We go to alert section here. Section, and now we choose multiple login failure. They will list all the multiple login failure that happened in the system in our virtual machine. So we go to open in search. Here they will list all the failure that happened like this. So the keyword is authentication and fail that I already set up for the keyword that we need. Here it's already stated that attacker _1 failed to authentication. So there's 2 here, 3. There's 3 here. 1, 2, and 3. It's already stated here. So I think that's all from me. And I pass to the next presenter. Thank you.
I am Anastasia and I will be presenting reflection and challenges. In this project, our team is provided with an opportunity to apply knowledge of network security to a real-world scenario involving data science and data overhead. Based on the assignment 1, we expanded the network design by implementing security tools such as VLAN segmentation with SCLs, AAA, protocols, VPN, GRE, and SIM SIM to address identified vulnerabilities. For reflection, our group learned the importance of reinforced layer defense strategy where VLAN segmentation control internet access, VPN secure remote network connection, and SIM provide comprehensive monitoring. Next, we figured how to balance security with usability by making sure the configurations like VPNs did not set back performance while providing strong protection. Lastly, the project also introduced the importance of teamwork as we divided tasks, collaborated, and conducted peer review to catch errors in configurations like SCR roles and subnet masks. Next, challenges. However, we faced several difficulties and tested our technical and organizational skills. Minor errors in subnet mask or wrong order of rules can disrupt connectivity when configuring VLANs and SCLs because it requires precision. By implementing VPN, GRE, many complexities arise, particularly in maintaining stable tunnels and troubleshooting. It is time-consuming by integrating AAA protocol with VLAN as we work to ensure seamless authentication across the network. During SIM implementation, using Ubuntu and Splunk as tools, we also face difficulties, especially in resource allocation for the virtual machine and proper configuration of log collection from all network devices. Although challenges can be hard to us, it teaches us how to grow and learn. We now understand better how to plan carefully, adapt to problems, and keep improving our skills. In the future, we want to try using automation tools and better security system to make our work easier. This project taught us how to work as a team and solve problems together. Everyone worked hard and contributed equally. That's all from us. Thank you.